Okay, so hello and welcome back. So the next thing that we have in this chapter is exercise 3.3. Well, when I was doing, of course I haven't uploaded those videos to YouTube, but when I was doing mathematics class, I started from, these NCERT books, I started from class 6 and 7 and 8 and 9 and 10, 11. When you're in class 6, 7, 8 or so, the chapters are not, it will take you, for example, at most probably 1 or 2 days to complete, if you want to do everything and if you want to record everything. But these chapters are long, and they have a lot of exercises in them, and you have to do them all. So I do not really know what I would do if I was a student in India. I was once a student in India and I didn't like it because there was just no time. But well, that's the way it is, and of course I should tell you that I feel compelled to say this to you, that these books are actually very, very, the text that you have here is a huge opportunity that you have. And of course the volume of the material is a little bit too much, but that's primarily why Indian students are very good at mathematics. Wherever they go in the world, they are good at mathematics. And math is, as far as we are concerned, the most important thing in the whole universe, except for the universe itself, of course. Okay, so now exercise 3.3, and question number 1, we want to find the transpose of these matrices. For example, if you have some matrix, for example A, and it's a column matrix 5, 1/2 and -1, and the transpose of A becomes A prime, which is a row matrix 5, 1/2 and -1. And part 2 of this question is, for example, some matrix, let's call it B, 1, -1, 2 and 3, and then B prime becomes basically 1, -1 and 2 and 3 here. 1, -1, 2 and 3 here. Or if you have some matrix C, for example, as -1, 5, 6, square root of 3, 5, 6, and 2, 3, -1, then the transpose of C is basically -1, 5, 6, -1, this is positive 5, 6, and square root of 3, 5, 6, square root of 3, 5, 6, and 2, 3, and -1. So that is your matrix, your matrices. Question number 2, you want to find, basically you have two matrices A, which is basically -1, 2, 3, and 5, 7, 9, and -2, 1, 1. And one thing that I need to mention here is that, of course, all of these exercises, of course, you know that you have to do it on your own. And well, I'm doing them over here just as a reference for you. If you have any problems with these, with the exercises, of course you can come over here and consult the exercises, but it's important that you do them on your own, so that you can practice your own mathematics, because looking at me solving a couple of examples is not going to develop your mathematical skills, of course. In order to develop your mathematical skills, of course, you have to solve the problems yourself. And of course, one more thing that is important is that understanding, a part of understanding the concept is actually doing the exercises. It is while doing the exercises that you actually get a lot of insights into the concept that you did before. Meaning that just going through the concept is absolutely not enough to understand the concept. The exercises, all of the exercises that you see in all of these chapters are a necessary part of understanding the concept. Other than that, there is no other way to learn that. And I have some other matrix B, which is equal to -4, 1, -5, and 1, 2, 0, and 1, 3, 1. And I want to verify that A plus B whole prime. A plus B whole prime is the same thing as A prime plus B prime, right? So if I do A plus B, if I add A and B together, what I will get is basically these two matrices added together, which is -5, 2 plus 1 is equal to 3, 3 plus -5 is equal to -2, 5 plus 1 is equal to 6, 7 plus 2 is equal to 9, 9 plus 0 is equal to 9, -2 plus 1 is equal to -1, 1 plus 3 is equal to 4, and 1 plus 1 is equal to 2. And then what you have here is, this is A plus B. Now in order to basically create the left hand side of this equation, I have to take the transpose of this, which means that A plus B whole transpose is the transpose of this matrix. And in order to create the transpose of this matrix, I take the first row, for example, and make it the first column. The second row becomes the second column. The third row becomes the third column. Meaning that this first row becoming the first column would be -5, 3, and -2. Second row becoming the second column would be 6, 9, and 9. And the third row becoming the third column would be -1, 4, and 2. And so that's A plus B whole prime. Now A prime plus B prime, in order to create this part of the equation, or the right hand side, I have to calculate first A prime, which is basically the transpose of this matrix. Again, I have to make this first row the first column here, the second row the second column, the third row the third column. So I have -1, 2, 3, 5, 7, and 9, and -2, 1, 1, and that is A prime. Now, by the same logic, B prime is going to be equal to -4, 1, -5, 1, 2, 0, and 1, 3, 1. And so that becomes B prime. Now A prime plus B prime, to basically build the right hand side of this equation, I have to add these two matrices together. Meaning that I write -1 plus -4 is -5, 5 plus 1 is equal to 6, -2 plus 1 is equal to -1, 2 plus 1 is equal to 3, 7 plus 2 is equal to 9, 1 plus 3 is equal to 4, 3 plus negative 5 is negative 2, 9 plus 0 is equal to 9, and 1 plus 1 is equal to 2. And therefore, that is A prime plus B prime. Now, if you compare A prime plus B prime and A plus B whole prime, you can see that you have the exact same matrices. And that basically means that A prime plus B prime is the same thing as A plus B whole prime. And that is one of the rules of, one of the properties of, one of the properties that we talked about in this chapter. Okay, so now basically one more thing which is also important is that if basically we said that A plus B whole prime is equal to A prime plus B prime, if you write A minus B whole prime, that is equal to A prime minus B prime. So meaning that A prime plus B prime is equal to A prime plus B prime, and A minus B prime is equal to A prime minus B prime. And in order to show that, I can actually keep all of this. I can basically, let's do the whole thing over and over again. And let's say that you have you want to verify that over here. You want to verify that basically A minus B whole prime is the same thing as A prime minus B prime, right? So now in order to do that, so first I want to create A minus B. So A minus B is equal to basically this matrix subtract from this matrix, or you can say you can add the negative of this matrix to this matrix. But it would be reasonable for me to say that basically A minus B would be, for example, negative 1 minus negative 4, which would be, for example, negative 1 minus negative 4 is negative 1 plus 4. That would be 4 minus 1, which is equal to 4 minus 1, which would be equal to 3. Or 2 minus 1 is equal to 1. Or 3 plus 5 is equal to 3 minus negative 5 is equal to 3 plus 5, which is equal to 8. Or 5 minus 1 is equal to 4. Or 7 minus 2 is equal to 5. 9 minus 0 is equal to 9. Negative 2 minus 1 is equal to negative 3. 1 minus negative 3 is equal to negative 2. And 1 minus 1 is equal to 0. So that is A minus B. Now, A minus B whole prime, which is the transpose of this matrix, is therefore going to be, take all the rows and make columns out of them, meaning that this becomes 3, 1, for example, 8, 4, 5, 9, and negative 3, negative 2, negative 3, negative 2, and 0. And therefore, you have A minus B whole prime. Now, to create A prime minus B prime, I would write A prime is equal to the transpose of this matrix, which is negative 1, 2, 3 as a column, negative 1, 2, 3 as a column, 5, 7, 9 as a column, and negative 1, 2, negative 2, 1, 1 as a column, negative 2, 1, 1 as a column, and also B prime is the same, is the transpose of this matrix, which is, for example, negative 4, negative 5 as a column, negative 4, 1, negative 5 as a column, 1, 2, 0 as a column, and 1, 3, 1 as a column. And therefore, A prime minus B prime therefore A prime minus B prime is basically, I can say for example, -1 minus -4, which is -1 plus 4, which is equal to -3, 5 minus 1 is equal to 4, -2 minus 1 is equal to -3, 2 minus 1 is equal to 1, 7 minus 2 is equal to 5, 1 minus 3 is equal to -2, 3 minus -5 is equal to 3 plus 5, which is equal to 8, 9 minus 0 is equal to 9, 1 minus 1 is equal to 0. And as you can see, if I compare A prime minus B prime to A minus B whole prime, you can see that so -1, there must be something wrong here. So B prime is basically -4, 1, -5, and 1, 2, 0, and 1, 3, 1. That is correct. And A prime is basically -1, 2, 3, 5, 7, 9, and -2, 1, 1, right? And now A prime minus B prime is -1 minus -4, which is -1 plus 4, which is equal to +3. And therefore what I have here is, if I compare these two matrices together, I get 3, 4, -3, 1, 5, -2, 8, 9, and 0. And therefore I can say that A prime minus B prime is equal to A minus B whole prime. And that is basically what we wanted to prove here, or to verify here. So this was question number 2. This was question number 2. Now question number 3, we have if A prime is equal to 3, 4, -1, 2, -1, 2, 0, 1, and if B is equal to basically -1, 2, 1, 1, 2, 3, you want to verify that A plus B, you want to verify that A plus B whole prime is equal to A prime plus B prime. A prime plus B prime. So of course you in order to create, for example, A plus B, so based on the matrix A prime, I can conclude that A is the same thing as A prime whole prime, meaning that I have to take the transpose of this matrix, which means that this column becomes one row here, meaning that I have 3, -1, and 0, and 4 to 1, and 4 to 1, and then I have and so this is basically the matrix A. Now A plus B would be these two matrices put together or added together, which is the same thing as basically -1 plus 3 is equal to 3 minus 1 is equal to 2, and 2 plus -1 is equal to 2 minus 1 is equal to 1, and 1 plus 0 is equal to 1, 1 plus 4 is equal to 5, 2 plus 2 is equal to 4, 3 plus 1 is equal to 4. And therefore A plus B whole prime is the same thing as the transpose of this matrix, which becomes 2, 1, 1 as a column and 5, 4, 4 as a column, and That is a plus b whole prime. Now a prime plus b prime, we can calculate b prime here as well. So b prime would be the transpose of this matrix. So I write basically this row as a column, negative 1, 2, and 1, 1, 2, and 3. And now a prime plus b prime is equal to this matrix plus this matrix. So I have 3 plus negative 1 is equal to 2, 4 plus 1 is equal to 5, negative 1 plus 2 is equal to positive 1, 2 plus 2 is equal to 4, 0 plus 1 is equal to 1, and 1 plus 3 is equal to 4. And so a prime plus b prime is the same thing as, so then you can say that a plus b whole prime is the same thing as a prime plus b prime. A prime plus b prime. And that is part 1 of question number 3. Now part 2 of the same question is you want to verify that a minus b whole prime is equal to a prime minus b prime. Now to calculate a minus b, I have to, that is a and that is b, so I have to subtract this matrix from this matrix, which means that I have 3 minus negative 1 is 3 plus 1 is equal to 4, negative 1 minus 2 is equal to negative 3, and 0 minus 1 is equal to negative 1, 4 minus 1 is equal to 3, 2 minus 2 is equal to 0, and 1 minus 3 is equal to negative 2. And that is a minus b, and therefore a minus b whole prime is the transpose of this, which gives me 4, 3, negative 4, positive 4, negative 3, and negative 1 as a column, and 3, 0, negative 2 as a column. That is a minus b whole prime. And then a prime minus b prime would be this matrix minus this matrix, which is going to give me 3 minus negative 1 is 3 plus 1 is equal to 4, 4 minus 1 is equal to 3, negative 1 minus 2 is equal to negative 3, 2 minus 2 is equal to 0, 0 minus 1 is equal to negative 1, 1 minus 3 is equal to negative 2, and therefore you can say that a minus b whole prime is the same thing as a prime minus b prime. That is basically what we wanted to show. That was question number 3. Now question number 4, we have the following. Okay, so so now question number 4, you have basically if a prime, you have question number 4, you have a prime as a matrix of negative 2, 3, for example, 1 and 2, and b is another matrix of negative 1, 0, 1 and 2, and you want to find a plus 2b whole prime. So A, based on A prime, if you take the transpose of A prime, you would get to A, which is equal to, basically the transpose of this matrix would be negative 2, 3, and 1 and 2. And so A plus 2B would be equal to A, which is negative 2, 1, 3, and 2, and plus 2 times B, which is negative 1, 0, 1, and 2, which is equal to negative 2, 1, 3, 2, negative 1, 3, 2, and plus 2 times negative 1 is equal to negative 2, 0, 2, and 4, which is equal to negative 2 plus negative 2 is negative 4. 1 plus 0 is equal to 1, 3 plus 2 is equal to 5, and 2 plus 4 is equal to 6. Now, taking the transpose of this, A plus 2B whole transpose is equal to the transpose of this matrix, which would give me negative 4, 1, and 5, 6. And that is question number 4. Negative 4, 5, 1, 6. These are simple questions that of course anybody can do, and I'm sure that you can do that as well. But it's usually not a good idea to skip them. For example, right now I would skip these exercises and leave them to you, but well, you might actually find something new in them, so it's almost always beneficial to do that. Number 5, you have, at the most, even if you don't achieve anything in these exercises, is that you're practicing with your arithmetic, you're practicing with concentration, you're practicing with, for example, all the topics that you've learned before. For example, there is trigonometry in there, there is, again, arithmetic in there, there is all kinds of things in there, so they are almost always beneficial. Now, question number 5. For the matrices A and B, verify that AB whole prime is equal to B prime times A prime. And remember that AB whole prime is not equal to A prime B prime. It is equal to B prime A prime. So that is something that you need to remember. Now, the matrices that I have are, number 1 is basically A is equal to 1, negative 4, and 3. And B is negative 1, 2, 1. And so A times B is the same thing as 1, negative 4, 3 times negative 1, 2, 1, which is this is a 3 by 1 matrix, this is a 1 by 3 matrix, so I get a 3 by 3 matrix. So 1 times negative 1 is equal to negative 1, 2, and 1. And then you have negative 4 times negative 1 is equal to positive 4, negative 8, and negative 4, and negative 3, 6, and 3. That is A times B. Now A times B whole prime is the transpose of this matrix, which is negative 1, 2, 1, 4, negative 8, negative 4, and negative 3, 6, and 3. that is AB whole prime. Now here I can calculate A prime and B prime. So A prime is equal to the transpose of this matrix, which is 1, negative 4 and 3, and the transpose of B is equal to negative 1, 2 and 1, and then A B prime times A prime, B prime times A prime is equal to negative 1, 2, 1 times this matrix, which is 1, negative 4 and 3, and this is a 3 by 1 matrix. This is a 1 by 3 matrix, so we'll get the 3 by 3 matrix. So negative 1 times 1 is equal to, so you'll get a negative 1, positive 4, negative 3, 2, negative 8, and 6, and 1, negative 4 and 3. And so you can see that AB whole prime, which is this matrix, is actually equal to B prime times A prime. Therefore, AB whole prime is the same thing as B prime times A prime. And that is the first part of this question. Now the second part of this question, the matrices A and B are different, meaning that A is equal to 0, 1, 2, and B is 1, 5, and 7, and therefore you can, and you want to verify that AB whole prime is equal to B prime times A prime. Now in order to do that, A times B is equal to 0, 1, and 2, and that multiplied by 1, 5, and 7, and so you have a 3 by 1 matrix here, you have a 1 by 3 matrix here, so you get the 3 by 3 matrix. So the first row becomes all zeros because you're multiplying 0 here. The second row becomes the same thing, 1, 5, 7, and twice all of this would be 2, 10, and 14. And so that's A times B. And therefore A times B whole prime is the same thing as the transpose of this matrix, which gives me 0, 0, 0, 1, 5, and 7, and 2, 10, 14. Now what is B prime times A prime? So B prime is the same thing as this matrix. Take the transpose of that, 1, 5, 7, and A prime is basically this matrix, so 0, 1, and 2, and therefore B prime times A prime is equal to 1, 5, 7 times 0, 1, 2 is the same thing as you will get a 3 by 1, 1 by 3. So you have basically a 3 by 3 matrix. So that's 0, 1, 2, 5, 0, 5, 10, 0, 7, 14. This is supposed to be this way, and this is a 14, and this is B prime times A prime. So you can see that you have the exact same matrix, meaning that AB whole prime is equal to B prime times A prime. And that is question number 5. Now question number 6 is if 1, A is equal to this is question number 6. If A is equal to this matrix as cos alpha, sin alpha, negative sin alpha, and cos alpha, and then you want to verify that A prime times A is equal to I. Now A prime is equal to basically sin alpha cos alpha sin alpha, and then you have negative sin alpha cos alpha. And if I do this calculation, A prime times A, I will have cos alpha negative sin alpha times cos alpha and A is basically cos alpha sin alpha negative sin alpha cos alpha, and so you will have basically this row, this column, I'll have cos squared alpha plus sin squared alpha, cos squared alpha plus sin squared alpha. This row, this column, you have cos alpha sin alpha minus sin alpha cos alpha. Then you have second row, first column, which is sin alpha cos alpha time minus, so sin alpha cos alpha minus cos alpha sin alpha. And then the second row, second column, you have sin squared alpha plus cos squared alpha, sin squared alpha plus cos squared alpha, and say that this is your matrix. And then you have basically cos squared alpha plus sin squared alpha is equal to 1. Cos alpha sin alpha minus sin alpha cos alpha is equal to 0. Sin alpha cos alpha minus cos alpha sin alpha is equal to 0. And sin squared alpha plus cos squared alpha is equal to 1, which is equal to the identity matrix I, and therefore A prime times A is equal to I. That is part 1 of question number 6. Part 2 of the same question, you have A is equal to basically sin alpha cos alpha negative cos alpha sin alpha, and you want to verify that A prime times A is equal to I. So A prime is equal to basically sin alpha cos alpha negative cos alpha sin alpha. So this row becomes a column here, and this row becomes a column here. And now if I write A prime times A, I will have sin alpha negative cos alpha times sin alpha, and multiplied by A, which is actually that is A prime, that is correct, and A would be sin alpha cos alpha and negative cos alpha times sin alpha, and you would have first column, so sin squared alpha plus cos squared alpha, sin squared alpha plus cos squared alpha, Sine alpha cos alpha minus sine alpha cos alpha, sine alpha cos alpha minus sine alpha cos alpha, and then you have cos alpha sine alpha minus cos alpha sine alpha, and then you have cos squared alpha plus sine squared alpha, which is basically the same thing as 1, and this is sine alpha cos alpha minus sine alpha, that is 0. Sine alpha cos alpha sine alpha minus sine alpha cos alpha is equal to 0, and here you have 1, and that is equal to I. Therefore, A prime A is equal to I. Of course, you can understand that this is only about A. This is no rule in any way, meaning that you cannot say that in the case of any matrix, the transpose of the matrix times the matrix is equal to the identity matrix. It doesn't, of course. It's not necessarily so. For some matrices, you might get the same result. Now, question number 7, you have show that the matrix A is a symmetric matrix. So you have a matrix as A is equal to basically 1, negative 1, 5, and negative 1, 2, 1, and 5, 1, 3. And you want to show that A is symmetric. So, okay, so so basically a symmetric matrix means that A prime is equal to A. If you have a square matrix and basically suppose that, for example, A is a square matrix, and if A prime is equal to A, then that means that A is a symmetric matrix. I mean that by definition would be a symmetric matrix, which means that the only thing that I need to show is that A prime is equal to A, which if I calculate A prime here, I would get, for example, 1, negative 1, 1, negative 1, 5, and negative 1, 2, 1, and 5, 1, 3. And you can see that I have the exact same matrix, therefore A prime is equal to A, therefore A is symmetric. A is symmetric. On the other hand, I have a matrix that as A is equal to basically 0, 1, 0, 1, negative 1, negative 1, 0, 1, and 1, negative 1, 0, and you want to show that A is a skew symmetric matrix. So a skew symmetric matrix is basically if you have a some matrix A as a square matrix, if A prime is equal to negative A, then you can call A is a skew symmetric matrix, which means that I calculate A prime, and that is basically 0, 1, negative 1, negative 1, 0, 1, 1, 0, 1, negative 1, 0, and also negative A is equal to, is multiplying negative 1 by each and every one of these elements would give you 0, negative 1, 1, 1, 0, negative 1, and negative 1, 1, 0. And you can see that basically A prime is equal to negative A, and therefore A is a skew symmetric, not square, but skew symmetric Skew symmetric matrix. So that was question number 7. Now question number 8 is, for which we don't have much space left. So question number 8 is for the matrix A, and A is basically this matrix as 1, 5, 6, 7, and you want to verify that A plus A prime, this is not A prime, A plus A prime is a symmetric matrix. Right? So if I if I calculate A prime here, or A, the transpose of A, I get 1, 5, 6, 7, and then A plus A prime is equal to basically these two matrices added together. 1 plus 1 is 2, 5 plus 6 is 11, 6 plus 5 is 11, and 14. And a symmetric matrix means that basically the transpose of the matrix is equal to the matrix itself. Meaning that if I calculate A plus A prime whole prime, that is going to be equal to, the transpose of this would be 2, 11, and 11, 14. And you can see that 2, 11, 11, 14, you can see that A plus A prime is equal to A plus A prime whole prime. Therefore, A plus A prime is symmetric. And also you want to verify that A minus A prime is skew symmetric. And of course this was one of the theorems that we proved, right? So then what we have here is A is a matrix as 1, 5, 1, 5, 6, 7, and you want to verify that A minus A prime is skew symmetric. In order to do that, what I will do is first calculate A prime, and that is 1, 5, 6, 7. Now A minus A prime is equal to basically this matrix minus this matrix, so 1 minus 1 is equal to 0, 5 minus 6 is equal to negative 1, 6 minus 5 is equal to 1, and 7 minus 7 is equal to 0. And a skew symmetric matrix means that the transpose of the matrix is equal to the negative of the matrix. Now the transpose of this matrix, A minus A prime whole prime, is equal to 0, negative 1, and 1, 0. The negative of this matrix, negative of A minus A prime, is equal to 0, positive 1, negative 1, 0. And you can see that they are exactly the same matrices, so you can say that A minus A prime whole prime is equal to negative of A minus A prime, and therefore A minus A prime is skew symmetric. Now question number 9 is you want to find basically 1/2 of this and 1/2 of that when A is equal to that. So So suppose that this is question number 9. Suppose that A is equal to this matrix as 0A, 0A and B, negative A, 0 and C, negative B, negative C, and 0, and you want to find 1/2 of basically A plus A prime, and 1/2 of A minus A prime. And you know that both of these two matrices, I mean, this matrix would be a symmetric matrix, and this matrix would be a skew symmetric matrix. And we showed that basically any square matrix A can be written as a sum of a symmetric and a skew symmetric matrix, and I can particularly write here as A as 1/2 of A plus A prime plus 1/2 of A minus A prime. And then this would be the skew symmetric matrix, this would be the symmetric matrix. And that's the theorem that we talked about. Now this is just about calculation, right? Of course. So so now over here, if I write basically, if I find A prime is the transpose of this matrix, which is 0AB, negative A, 0C, and negative B, negative C, and 0. Now, 1/2 of A plus A prime, 1/2 of A plus A prime would be equal to basically 1/2 of basically this matrix, and A plus A prime would be these two matrices added together. So 0 plus 0 is equal to 0, A plus negative A is equal to 0, B plus negative B is 0, negative A plus A is equal to 0, 0 plus 0 is 0, C plus negative C is 0, and negative B plus B is equal to 0, negative C is 0, 0, 0, and that's equal to basically 0, 0, 0, 0, 0, 0, 0, 0, 0, which is equal to O. Which means that basically 1/2 of A plus A prime is actually equal to O. Right? That is equal to O. Now 1/2 of A minus A prime is equal to 1/2 of basically this matrix minus this matrix. 0 minus 0 is equal to 0. A minus negative A is A plus A, which is equal to 2A. B minus negative B is B plus B is equal to 2B. And negative A minus A is equal to negative 2A. 0 minus 0 is equal to 0. C minus negative C is C plus C is 2C. And negative B plus negative B minus B is equal to negative 2B. And negative C minus is negative 2C. And 0 minus 0 is equal to 0. And that's the same thing as basically 0, A, B, and negative A, 0, C, negative B, negative C, and 0. So that is basically 1/2 of A minus A prime. And now, of course, if you add these two together, you should get A, which is because basically this is a 0 matrix. Then this must be the same thing as A, which is 0AB, negative A, 0C, and negative B, negative C, and 0, and that is correct. So that was question number 9. didn't understand why they actually have asked this question, but okay. Question number 10. We have expressed the following matrices as a sum of a symmetric and skew symmetric matrix, and we have 4 of them here. Then we have 11 and 12. So I guess we will end this video here, and then we will continue in the next video. See you in the next video, and thank you.